Hey students, Saxon Algebra 1, Lesson 52. You guys, we worked on this in class. We covered the first half of it, but you were tired and, excuse me, it was the end of a long day. I'm going to cover both pieces of it. We were originally planning just to do part B, which we didn't do in class, but I'm just going to do part A again. It was about adding rational, which means fractions with lots of letters. Rational expressions. Okay, so this is a review. What? A review. Just to freshen your brain. 52.1, the instructions are to add. And what we get, as you will recall, is a lot of letters in fraction format. And we know that if we're adding fractions, letters or numbers, they still have to match. And we know that there's no way to make this x look like this plus y. All we can do is least common multiples. We cannot add to one or the other denominator. So in this case, our least common multiple is going to be x times the quantity x plus y. Okay, we don't have any equal sign here, so we'll have to adjust by multiplying top and bottom by the part of the least common multiple we don't already have. We know that we want both denominators to look like this in the end. So if you want, you can write that down first. That's what I'm going to do this time. And then you can look back and see, okay, this side needs the x plus y, and this side needs just the x. Notice that, I didn't need parentheses here, but notice that I'm putting parentheses around the binomials so that I don't mess them up. Okay, so we've multiplied top and bottom, matches, and now we can write the numerator. I'm just moving the a over to this side because I like it better on the left than I do on the right. And this one, there's nothing to do but squish them. And now our final step is to make one big fraction out of this. And that's our final answer. Double checking. Yes. John makes the point, and I talked about this in class, that you have options here. If you wanted, you could distribute the a. If you wanted, you could distribute the x. Distributing or factored form, we call this the factored form. Neither one is better or worse. As I mentioned, excuse me, tuberculosis. As we mentioned in class, either way is fine. When John presents it one way and you've got it another way, just check to make sure that they are equivalent forms. But this is the way John presented it, so we don't have to worry about it. I know, you were stressed by the notion that my form might not match to John's. I know. Okay, 52.2, add 4x plus a over a plus b plus c over x. Okay, same thing. We want to set up our least common multiple. We have to make the denominators match. There's no way we can get those two to look alike except to multiply. This time I'm not going to do this. I'm going to just look and use my noggin. This will need an x over x, putting parentheses around the binomials. And this side is going to need the a plus b, squishing a little bit to make it fit. All right, now both my denominators look nice, and so I just need to do the top. X times the quantity, 4x plus a, and quantity, plus c times the quantity, a plus b, and it's all over x times the quantity a plus b, which is right here. That's a b. Should we just check quickly? Okay, now John has distributed in this example, so let's take the extra step of distributing and see if our answer matches his. I get 4x squared plus ax plus ac plus bc. He distributed the top but not the bottom. That's an x. So I'll leave my denominator undistributed, and now let me check. 4x squared plus ax plus ca, he has it in the opposite order, plus cb, opposite order, over the quantity x, over x times the quantity a plus b. So this is the format his answer was in. I easily got there by distributing my answer. So, yay. Okay, second example. Third example. There's so many examples in this lesson. I was skipping around in class and just picking the ones that look different. Okay, again, we're asked to add a plus b over x plus c over m plus, John gives us a floaty d. You know how I feel about floaties. I don't like them. So I'm putting my d over 1 immediately. Least common multiple, I'll write it on the left side this time. We don't have any binomials in the bottom. That's kind of cute. Our only binomial is here. So it's mx. I don't have to include the 1. So once again, I'm going to multiply top and bottom by whatever piece that fraction needs to end up with mx. So this one will be m over m. This one will be x over x. And this one will be mx over mx. I kind of like it with the line. Don't need it, but I like it that way. Okay, and so now I'm going to write this as one giant numerator. M times the quantity a plus b plus cx plus dmx. Oh, we did this one in class because I remember Micah having issues with it. Micah Bradley Cooper Pitt or his he out? I'm not sure. Richmond. Mx. All right, let me double check against the answer. M times the quantity a plus b plus cx plus dmx over mx. John agrees. Good job, John. That one's right. 52.4. It's the last one, and then we switch to the other section. Okay, add a over b plus c minus x. Again, it's a floaty x. I'm not having it. Plus d plus m over k. All right, I see two binomials. Sometimes I just wait and put the parentheses around the binomials as I go, but sometimes when I'm in a different mood, I like to put the parentheses on the binomials right away so that I don't forget and screw it up, because that's never a good look. Least common multiple. All right, k times the quantity b plus c. You know, I always just cringe a little bit when I have to write that, but there is no better way, people. That's what we have to do. Okay, so then no equal sign. It's just an expression. So I'm using the third rule of algebra, and I'm multiplying top and bottom by the same quantity, whatever it takes to get the denominator to this. So for this first one, it's k over k. And for this one, oh, it's the whole thing. K b plus c quantity. And I'll write it by the bottom too. That's kind of overkill, but that's okay. I don't mind overkill. And this has got the k. Oh man, look at this. So we have to do the b plus c and b plus c. Isn't that attractive? Okay, now we're ready to make sense of this gigantic numerator. Okay, a times k, ac. And this is that a minus or a plus? Let me check the book. That's a minus. It doesn't make any difference in our work, but we want to get that straight. I'm going to go alphabetical. Kx, these two are on the outside, and then we have the b plus c on the inside. And then this is a plus, and then we have the binomials, d plus m times the quantity b plus c. All of this monstrous beast is over k times the quantity b plus c, which again, that was our least common multiple. Those should always be the same, right? All right, let's look and see if John did any distributing. Here's what he has. Ka, okay, reversed, minus xk, reversed, times the quantity b plus c, plus quantity d plus m times quantity b plus c. Okay, he's written it just like us, over k times quantity b plus c. Yay! I'm always so happy when it works out, aren't you? In your homework, it's like, you're rocky, right? You're like trotting around your room. You're just feeling so good about it. All right, that was 52. Like I said, we already did it in class, but I felt like it needed a little more attention. Part B is what we didn't do, and it's called overall average. And I just want to jump into the example because I'll be able to explain it better when we have a situation in front of it. The average of the first 90 numbers was 4. The average of the next 10 numbers was 6. What was the overall average? Okay, first let me draw a picture to explain what this is. We have a bunch of numbers, 1 through 90. We don't know what they are, but there are 90 numbers. We added them up, we got a total. We divided it by 90, and we got 4. The average of the first 90 numbers was 4. That's what this is worth. That's what this tells us. Now, we don't know those 90 numbers, but working backwards from here, we know they had to add up to 360, right? Because 360 divided by 90 gives us the average of 4. We still don't know these numbers, but we know they added to that. So this was scenario 1. Then we had more numbers. We had another 10 numbers. So let's call this 91 through 100. These were totaled and divided by 10, right? There were only 10 numbers here. There were 90 numbers here. And their average was 6. Okay, what was the overall average? Oh, I'm sorry, I didn't finish this part. If the average was 6 and there were 10 numbers, then this had to add up to 60, right? Now we want to find the overall average. Some people want to just take the 4 and the 6 and say, oh, the overall average is 5. No. We can't do it that way because 4 represents 90 numbers and 6 only represents 10 numbers. So we have to weight this to take into account that the 4 represents a lot more numbers. So here's how we do it. We take 360 and we add 60 for the total points altogether, which is 420. Then we take the number of items. This represented 90 items. This represented 10 items. So we had 420 total points, if you will. I don't know what those represent. I think of them as points on a test. Maybe not. But the actual items added together came to 420, and there were 100 of those items, so the overall average is 4.2. That's the way that works, all right? And this is, John shows it as a formula. This is the sum of the numbers. I'm using the hashtag sign in the old-fashioned way. The sum of the numbers, right, is 420, and we divide it by the, it's confusing, number of numbers, okay, which was 90 plus 10, 100. So if you want to use this as a little formula to help you on your way, you can. I like to visualize the work like that and then take the total and the totals and find the proper average. This is the right answer, by the way. All right. There's only the one problem for this, so I hope that it makes lots of sense when you do it in your homework. Good luck.